Cheers. Hi, everyone. Thank you for joining this session that we're doing today on model monitoring. Just go through some intros first. So my name is Sonny Hamilton. I'm a lead data engineer in the data science team at LV, and I've been in the team now for around 3.5 years.
Yeah, hi, and yeah, my name is Dapeng Wang. I'm a senior data scientist in the team at approaching 3 years now at LV.
So just to give you a bit of an introduction to the data science team itself. So data science team at LV was started around 4 years ago, and we've currently got around 40 people at the moment. And the team is made up of both data scientists and also data engineers. And as a team, we've had a lot of success getting machine learning implemented in the business, and we've got around 20 models live so far.
Yeah, and how we work as a team is we work with the different business areas within LV and trying to help with the decision making through the use of machine learning. So just a little bit about LV, because depending on your internet history, when you search LV, Louis Vuitton might be the one that comes up. So I just want to be clear, we work for LV General Insurance, so we're an insurance company, not the other LV. So who are we? So yeah, what does general insurance mean? We sell insurance product to people like you and I. So we have over 7 million customers in the UK. We're one of the largest insurance companies in the UK, and we have a team of over 4,000 people. So we sell products like car insurance, home insurance, pet and travel, those type of insurances. And our goal as a company is to become the UK's best loved. So moving on to the talk, just a brief outline. So what we want to do is to tell you a little bit about the background on why we should do model monitoring. How do we monitor data, and what point do we consider? And then Sonny is going to talk about the implementation side of things. And if there's still time in the end, we can show an example. If not, we can skip that. So I think that the aim of this talk is that we are in our journey where so we implement model monitoring across the models that we deployed, but we learned certain things along the way. So the points that's mentioned here, I think if you want to implement your own model monitoring solutions or using, say, something that's open sourced, it's worth to consider the points that's mentioned, because those are things that creeps up when you like looking at the data, but when you search about model monitoring online, there's not that much talk about those problems. So as standard, yeah, in our analysis phase, we have our data that is collected from the business, and what we want to do is we want to answer a business problem, right? So for example, because we work for insurance, what's the classic example? Let's talk about fraud, right? So we want to predict a claim come in, is it fraudulent or not? Just as an example, right? So in the analysis phase, it's also already important to be able to understand our data, right? So for this case, model monitoring, or similarly data drift, we want to understand how our data changed over time, and then knowing that we can take appropriate actions. But if we don't know that, it could impact on the model performance. If things change over time, right? When you evaluate the data, you evaluate the model, you could have a really good performance or not so good performance. So then they have to go back and investigate. So in terms of understanding how the data change over time, is already important in the initial phase to do that. So once we do our EDAs, we do our analysis, we output our model, the next step is to deploy our model, right? But unlike here, right, our model is not always that accurate, and the deployment process is a little bit different than this. So what does it look like? So again, we have the data. Now it comes from the business, the core system in the business that people uses. So the data gets entered there. That data gets passed to our model, which is, so we package up our pipelines, our models into a live API so that the core system can call on our model. And then we return a response back into the business, and that is used by the end user to make certain decisions. So as you can see here, again, very important to understand how the data changed, right? Did the data change from the core system? Did it change inside our pipeline? Is that something we expect? And also the predictions that we give, is that something that changed over time? So we need to be able to explain those things. So the first thing that I want to clarify is, so when you Google monitoring solutions, they're usually talking about infrastructure side of things. So in this case, can think of like the memory usage, right? If the memory usage goes high or higher than what we expected, then that is something that's worth investigating. But for us, because we're deploying machine learning models, the problem is slightly different. So you can think, for example, each claim coming into our model or each request that's coming into our model, those are more like independent events and not really like a time series. So if we look at things over time, that might not give us a lot of information. And also there's more ways that the model can change. So the predictions can change, the data that's come into the model, that can change. And so it requires different monitoring solutions than, say, monitoring things like a time series or from the infrastructure side. So how can the model change, and what is the impact of that have? And in terms of the model monitoring solution, what is the impact of that? So the first thing is the target, right? So working with our example of like predicting fraud, right? We have claims come in, we want to give a decision, is it fraudulent or not fraudulent? Okay, so because we deploy our models as a live API, right? If you want to consider the target when we monitor our solutions, that can have its challenges because it takes time to investigate claim. Right? So our model can say it's a fraudulent claim, and then somebody actually needs to go in and then investigate that, and then and that could take a few months to even find is it a fraudulent claim or not. So the feedback loop there is quite slow, which makes incorporating the target into our monitoring solutions a bit unfeasible, or it could take a long time. Right? You don't want to wait for 3 or 6 months to know something actually went wrong, because that is way too late to be able to know that. So then what can we do? Well, we can monitor if there's a change in our predictions, right? And this is very important because the business, they have, when we deploy our solution, they have certain expectations on how our model will perform, right? So suppose our model performs like 10% of the time, we predict a fraudulent case, 90% of the time, not fraudulent case. Right? So if we don't monitor our predictions, that prediction can change. That could have a consequence later down the line. So if, say, suddenly now we're predicting 50% of the time that the case is fraudulent, yeah, that's again, people need to go and investigate that, and suddenly now their workload is increased by 5-fold. So they're going to come back and ask what's going on in terms of predictions. We can't deal with that much. But similarly, if we expect 10% of the case to be fraud, that the model predict, but then the model now only predicts 1% of the time that is fraudulent, again, that raises questions, and business can come back and say, yeah, what's going on? We don't really trust the model. because we expect there to be a lot more cases. And in terms of our solution, then we need to first be able to monitor that, but also be able to explain what is going on there. So when we deploy our solution, like that model is fixed. We deploy in the API. So we are not doing any online learnings at that stage. So then what can cause a change in the predictions? Then the only thing that can change is the input, right? So if you think about it like a group of data that we're predicting, that the percentage of claim is fraudulent could go higher or lower, but that depends on how the input changes to our model. So here it's very important again to be able to understand, is there an input change in our model, and then to be able to explain what is the change in the input and how is that impact on our model is very important. And finally, there could be a change in the behavior of the data that's coming in. So in the case of fraudulent claims, there could be a fraudster. They can do something and then maybe realize, oh, if I do it this way, I will be caught. So then I will change my behavior. So what does a change in the behavior mean? Again, that could mean a change in the input to our model. So as you can see, it's very important to first understand and monitor the predictions, as well as monitor our input. So just even before thinking about model monitoring solutions, right? That is like the solution that we use to monitor our models, but data can change even before hitting our models. So we need to be able to detect those changes upstream in the pipeline, say, for example, in the business core systems. So what I mean by that, so we have data come into our service as an API, as a JSON message. And in there, we expect data to be of a certain format, right? So for example, one of the fields could be the day of the week, right? That can take the value 1 to 7. So that is something that we expect it to be. So first we need to check, are those input values valid? If it value comes in as -1 or as 1.5, we know like something is going wrong, and we need to be able to alert the business so that those problems upstream can be solved. Similarly, checking the data type is like when we do our models, we expect fields to be of certain data type, and if that's not the case, then again, that can cause some problems. And then also, missing values. Weekdays, for example, it shouldn't be missing, right? So if a missing value comes in, depending on how you design the pipeline, that might not be able to deal with that. So in this case, again, we need to be able to identify that and raise the alert back to the business to be able to say, right, this is something is going on here. We need to investigate. Right. So when we're talking about how the data change over time, or in this case, how the data drift over time, like at least when I started working on this project, it's not very clear. Right? You think, oh, data can change from one place to another, but how did they change? So I find that this paper is quite useful, this learning under concept drift review. So this visualization that took from the paper, I think it really demonstrates that what is the different scenarios on how the data can change over time. And so why is this important? Well, so if you design a monitoring solution, right, you think, oh, maybe I want to check if there's an incremental drift or if there's a sudden drift. But the thing is, we don't really know, like when we deploy our model, how the data is going to change over time. So when we design a solution, we need to be able to capture those different type of behavior, whether it's incremental change or if it's a sudden drift, and then to be able to detect that. but that comes with its own challenges. Right? So one example is this idea of incremental drift. Right? I want to know if my data is changing. I compare today's data versus yesterday's data. So my test could be accurate enough to be able to detect that. But suppose the data changes very slow, right? Then the how you measure the change might not be able to detect how they changed over time. So then what can you do? Okay, you can make the test more sensitive, but then that also comes with a problem that you have noise in the data. So when your test becomes too sensitive, then you have a lot of false positives to say that how the data changed over time. So what we want is to have a high signal to noise ratio, right? Sorry, yeah, to be able to identify the different type of changes. Similarly, like in the idea of gradual drift or recurrent drift, right? If your time window, when you consider, I don't know, if you say, I want to consider 1 year worth of data, but if your data changes on a much shorter time period, then might not be able to detect that. So it's worth to bear in mind the solutions that you have, and also would those work in the different scenarios. So yeah, I recommend reading this paper. There's a lot of information there about how can we detect change, and yeah, very, very useful. Okay, so now we know that we want to monitor data over time. How do we do that? We want a group of data. So should we use descriptive statistics like the mean or the variance? So here is a famous example where we have the 4 distributions, both in the x-axis and in the y-axis, and we see the average and the standard deviation is the same, but clearly you see the distribution is very different. All right. So when we deploy our model, right, those changes in the distribution could have a significant impact on what the model is predicting. So if we just want to measure some like average, for example, we might not be able to capture the changes in the distribution, which means if we want to understand how our input change over time for each feature, we need to care more about checking the whole distribution, not just the statistics alone. Yeah. So then how do we measure change over time? So we now understand that we need to be able to measure how data change over time, where we compare one set of data against another set of data to determine is there a significant change. So in terms of the statistical test, what is the advantages? Well, so the statistical test is framed as a hypothesis test, right? You can either reject or accept the null hypothesis. So it's relatively easy to understand. Okay, my data have changed or haven't changed. But if you think about when you monitor a solution, or in our case, we need to monitor all of our models and all of our features, that really builds up. So we can have hundreds of features that we need to monitor. And then that runs to the problem of the multiple comparison problem. So suppose we want to reject our null hypothesis if the p-value is less than 0.5, right? And we have 100 features that we test on a daily basis. Then just by randomness, we expect at least 5 to reject the null hypothesis. So if you look, there's some papers to talk about actually the rate is much higher. So what did that impact going to have in our model monitoring solution? Well, somebody again needs to go and monitor that feature. And so if we say this feature have changed, then we need to manually understand what is the change, what is the impact of that in our model. So if we have a lot of false positive every day, right? First of all, that loses our confidence in how well we can monitor our solution, but also we might not notice the important things that changed because there's just a lot of work needed to check each individual feature. So this, how to define like this robust way of measuring is still an open question. But here I want to raise a question is, so suppose your data didn't have a p-value, say, greater than 0.5 when you do statistical test, right? So it didn't, it's not saying that we should reject the null hypothesis, but there could still be a little bit of change in the distribution. And is that the impact? Is that going to have impact on our models? No, it could still have impact even though we say the distribution is similar. Right? So what are some of the other approaches to be able to monitor if there's a change in the data? So we can use some distance metrics like to measure, for example, numerical values, to measure how much difference is there between the two distributions, and actually output a number which is interpretable. Right? So a smaller number means the similar the two distributions are, the bigger the number, the more dissimilar the distributions. And similarly for the categorical case, we can use things like KL divergence to measure how different is the two distributions. So that is good, because if you want to understand how have our data changed over time, now we can have a number to see, all right, it goes from 0, it's going higher and higher every day. That's something that we can measure and we can understand, right? But being able to like automate the process, right? We want to be able to trigger an alert to say, all right, this is now a change that needs to investigate. Then we need to be able to understand, right, how big is the number that is needed for us to trigger that change. And this is where it's slightly hard to do, because first then you need to establish what is the normal behavior of my data to be able to say, all right, this KL divergence value is much higher than what we normally expect, and this is where I need to investigate further. So for example, one way to do that is to just sample your data set many times to be able to understand what is normal, what is normally expected, and what is not normal. So that is quite good, because you can sort of establish what is your normal behavior, but there's like more problem that come with that. So in the case that here, I'm just giving an example, right? I know that earlier I said not consider the average to when you measure things, but just as an example here, let's consider it to understand the problem. Okay, so I have some numerical distributions. We have the mean. We expect the mean to be 1. And then in this case, we see for day 0, we have a normal distribution with mean of 0. And on day 1, we have a normal distribution with a mean of 2. Okay, so we can see clearly, if you expect the average to be 1, day 0 is quite different. Day 2 is quite different, right? But then because we want to consider a group of data at once, in this case, we want to measure how did the data change over time. So it makes sense to select the time window, right? And this is also a bit tricky, because if you select the time window in this case of 2 days, then we see if you combine day 1 and day 0 data together, then we have average of 1 again. So we won't be able to detect any changes that happens if we like increase our time window. So you can think even further, right? If you want to sample I don't know, a month or a year's worth of data, then anything that happens on a shorter time period, that will get smoothed out. So you won't be able to detect that. But similarly, if you want to sample at a really short time interval, if you don't have a lot of data there, then there can be a lot of noise, and that could also trigger a lot of false positive when you want to compare how the distribution changes over time. So one way, again, here to understand what is the best window to select is to understand your business problem, right? what do you expect the daily volume to come in as? How do you expect the data to change? Is it, can data change like on a daily basis? Can it change on a monthly basis? What do you want to monitor? And then you can design your solution to be able to capture that type of behavior. And then also here, just another example. Yeah, before we had numerical case, so now we're talking about the categorical case. So again, we have a group of data. We see a feature that can take value A, B, C, and D. And if we see it for day one, A takes 10% of the values, B takes 20%, C takes 30%, D takes 40%, and opposite for the day one. So then again, what happens if you sample both days together? That distribution is very different from if you consider those individual days. So it's quite important to be able to sample your data correctly rather than just do a lot of bootstrap samples, because what happens if you sample like randomly like this, right? Then you look at your data, okay, the data didn't really change over time, but actually it did change. And maybe that's something that you care about, is like if the data changed for 1 week or 2 weeks, because if you think about it, right, we deploy a model that's giving a prediction. If the input data changes, that can have a change in the output. It can change in the predictions, and then and that could mean that the business metric that the business evaluate on can change. But is that something that needs to be we need to take action on, or is there something that is just this is just what happens in this time period? That's again something that needs more investigation. So I will hand over to Sonny now to talk about the implementation side of things.
Thanks, Dapeng. So yeah, I'll be talking a bit about the implementation side of things and why model monitoring is an important step you'd want to include in your deployment strategy. So here on the screen, you've got like a basic high-level implementation pipeline where you created your model, packaged it up, and you deployed it. And hopefully it's being used, and fingers crossed it's also generating value for the business. But I think a lot of us would recognize that getting to this stage can be tricky for many data science teams, and it is certainly a really big achievement when it is reached. However, as big a success as it is getting to that stage, from my point of view, this is by no means the end of the journey, and it's certainly not the end of the story. So going on to the next slide, you'll see that rather than thinking of that kind of implementation process as a kind of a static process, I like to make it more as a cycle, which means that getting your model into production doesn't just begin and then end with creating a model and then deploying it. So in order to give your business users confidence that the model will be performing to a higher level, like going forward into the future for however long the model is being used, it does make sense to implement some monitoring of your model performance. And I feel that monitoring should be an explicit stage in your implementation setup. So as Dapeng has explained, for a number of reasons, your models can experience data drift, and this impacts the predictive accuracy of your model over time, and it can affect the outputs you get from your models. So if we assumed, for instance, that you didn't necessarily want to perform any model monitoring, I think this would carry some risk. So let's say, for example, let's assume that the model is producing some unexpected outputs, and this is negatively impacting business processes. Well, if this is affecting business processes, then the business may be experiencing some financial losses. And not only that, if it's affecting business processes, it could also impact the customer journey and perhaps the customer experience. So from this perspective, it could drive customers away to competitors. And I would say so as well, that ultimately if model performance gets worse and if it goes undetected especially, people may lose confidence in your model, and this could perhaps impact the reputation of your team and also any other models that you've built. So I'd say that implementing this model monitoring stage, it does help to manage these risks. and which is why I think it makes sense to have this as an explicit step in your implementation pipeline. But ideally, with these model monitoring tasks, kind of the statistical test that you want to perform, you don't want it to be like a manual static process. You want to be in a position where you can automate it all and practically react to changes in your production data. So going into the next slide now, the point I want to make here is that it would make sense to set up automated tasks for the model monitoring stage, and could be, for example, maybe running those tasks like once per day, so that whenever there's a statistical tests are run and a certain threshold value is reached, an alert could then maybe be triggered, and then this can act as like an early warning system whenever there appears to be like an issue with the health of your model. And then with this alerting system in place, I think you'll be in a better position to know when you have to retrain your models, rather than perhaps finding out when it's maybe already too late, it's gone undetected, and you're finding out because the business has lost money or there's complaints that you're losing customers. So the way I see it is that it'll pretty much turn that static implementation process into like an ongoing retraining cycle, so that it pretty much goes from where you've got the model live, you've got your model monitoring in place, and then you run those statistical tests on the model input data. And then you receive an alert which lets you know if something needs further investigation or not. And then from this, you're like doing this monitoring analysis at the right time, rather than kind of speculatively. And you're proactively determining whether your model requires a refresh or not. And just rather than it being like a reactionary process, as I explained, like if someone's complaining this is we're losing money or we lost customers, and you end up doing it too late. So yeah, it could help sort of counteract those kind of negative impacts. So going on to the next slide, and hopefully you can see why it's quite important to implement model monitoring. And on this slide here, I'm just going to go through what I think are the main benefits from implementing a model monitoring stage into your deployment and information process. So firstly, as a benefit, touched upon this a little bit already, but I think implementing model monitoring will increase the level of confidence in the performance of your models. And this is both from a business perspective and also from the perspective of your own team. And I know from experience, it can perhaps be sometimes quite a bit of a struggle for data science teams to get the business behind them and to believe in them and to like champion the use of machine learning. And by not using something like model monitoring, it's not like really, it's the last thing you want is like for that trust to be broken by not including this stage. And you don't want a badly performing model to sort of break that trust and to question the confidence in your team. As an additional benefit as well, I would say that with the monitoring step in place in your pipeline, you should have a better overall understanding and awareness of the health of your models in general. So if we're saying like if you're not using these model monitoring tasks, then you're deploying your models blindly. And then you're running the risk that like the changes in the characteristics of the input data that you might see in production could go unnoticed and cause those unexpected issues that I was talking about before. Also, in terms of another benefit, I'd say that from implementing model monitoring, you can better use the resource that's within your team, especially the data scientist resource. So for example, if you do automate those monitoring tasks and build a monitoring solution that will give you alerts, then you can free up that sort of precious time really that you've got on your data scientist to focus on other projects, on projects that add value, rather than having to deal with manual tasks that could pretty easily be automated. And this way, the team and the people on that team are just spending time on investigating the monitoring alert that's been generated, rather than just speculatively looking. And they can find any issues, and hopefully that'll be in advance of there being a major impact on your model, and that can be addressed ahead of time and potentially retrained. Also, I would say in terms of another benefit is that you will be in a better position just in general to prioritize the retraining of your models. You'll get a heads up, so to speak, of when things need to be trained, when the input data is changing. And I think that's always a good position to be in. And that's it from me on the implementation side of things.
Yeah, thanks, Sonny. And I think, yeah, it's important to stress that similar to implementing the machine learning project, it's very important to work together, both from data science as well as data scientists as well as data engineers, but also because we are not working in the day-to-day running of the business, right? If things happens inside the business, the person who is best placed to understand that is actually the end user. So so monitoring solutions is also a responsibility of the user or the business function that is using our machine learning models. And then, yeah, so one thing is to be able to understand and detect if there's a change in the data. And the next thing is, right, once we know there's a change, we need to be able to explain to the business this have changed and what is the reason behind the change. And sometimes the reason behind it, you need to go to the business to understand that, because that's maybe the business decide on changing a system without telling us, and then we don't know what's going on. But yeah, it's very, very important to work as a team together.
Perfect. Thank you very much, guys. And thanks for basically just sharing everything that you've been doing. I must admit, in terms of the model monitoring side of things, it's quite clearly commercially for the businesses so key. And I think one of the things that you touched on there in terms of that level of confidence, and it's actually a question I've got here just in terms of how that's impacted, but we'll get to that. But that was fantastic. Thank you. We've had a couple of messages coming on the chat just from Indranil and Hamed. So thank you very much for joining the chat there, guys. If you have enjoyed that, just watching along at home, it is quite nice for the speakers just to see the odd little thank you coming through in the chat, just to let them know that there's someone out there watching, which is always nice. In terms of questions, we have got a few questions coming through now, so we'll do our best to get through some of those. I guess one question I'd like to start off with, actually, from my side of things, before we get to the questions in the chat, and just as you were talking, it was how do you get that balance of complexity in the monitoring solutions, between the the human element and being a bit more complex with some of the models that you're talking about.
Yeah, question. So I think in some ways there will be some mix of the two approaches. So as I touched upon, like automating the monitoring solution is really good, but getting the human to assess the alert and then to determine how serious the problem is obviously also quite important. So the main benefit, the big benefit that you'll get from an automated monitoring solution, is that it gives you the ability to like schedule those monitoring jobs instead of having to like manually run the task and just speculatively do it when you're just like maybe not too sure if there's a reason to be doing it. So if you can implement like an alerting system, that'd be really great. I think there'll always be some element of like manual human monitoring though that needs to be involved. So for example, it could be like a one-off rare event that only has a short-term effect, such as maybe like a freak weather incident, and perhaps that doesn't suggest that like a refresh of your model is required. So like you need the human to assess that situation, or it could be like something more significant that actually tells you the characteristics of your production data has now actually changed, and your model does actually need a refresh for that reason. So yeah, I think there'll always be that human element to just assess the type of scenario and then to investigate further. But I'd say overall you want a good mix of the two approaches.
Yeah, perfect. That makes a lot of sense. In terms of going through these questions, well, as I'm calling them out, if either of you feel best suited to answer it, obviously just jump in. And equally, if you both want to have an input, again, just fire away. Don't rely on me. I'm going to jump over to some of the Q&A that come in now. So I'll be reading them out, but both of you can open the Q&A actually and be able to read along at the same time, which is sometimes helpful. In terms of that Q&A then, I'll go to the question that's at the top there from Andrew Middleton. Andrew's asking, have you done any monitoring on text data? If so, how do you calculate data drift metrics on this type of data? Is that something that you guys have come across?
So that is a really good question. So yeah, the talk is focused more on numerical features and categorical features. text is a bit harder to monitor, but again, it depends on how you implement your text in your model. Right? So suppose you, I don't know, find some keywords or your frequency of words happening, then you can monitor those things, which can be captured as a numerical or a categorical value, instead of monitoring just the raw text by itself. But yeah, really good question. I think it is something we're considering. Like, how do we improve our monitoring of text data in addition to doing it from like the numerical and categorical side?
Perfect. Thanks very much, Dapeng, and thank you for the question, Andrew, as well. We'll nip on now to the question there from Ian Sharp. Great to have you with us today, Ian. In terms of Ian's question there, first of all, he starts off by saying, great presentation. Curious to know what types of alerts are you using? Guessing standard predictive assessments, but do you also use some of the stats from measuring relative entropy, etc.? And as a follow-up, how big is big? At what point do you intervene to make some changes to the model?
Okay, that's again very good question. So let's see.
They're a good bunch, our community. Eh? They get straight to the heart of everything.
Yeah. So yeah, you can use like KL divergence as relative entropy to be able to monitor the categorical values. So if you think about your monitoring solution, first it's good to understand like what type of data you have, then you can choose the appropriate test. So maybe, I was saying the statistical tests are not ideal, but maybe depending on your business case, you might want to monitor it that way, or you can monitor it using some sort of distance measure. And to the next question of like how big is big, then that comes back to like what is your normal expectation. So maybe you can do some simulations on your data set to understand, right, this is a type of range of value that the metric can output, and then that can help you give a guideline on what you can say this is now suddenly too big. So again, in the solution, it's good to have those things to be configurable to say, all right, I want those parameters to be able to adjust, because each use case is different from another use case. So it's a bit hard to know for a in general, but you need to understand specific use case.
Yeah, that makes a lot of sense. Depends on the business and the project. Makes sense. Just jumping back to the chat, just super quickly. Thank you to Michael, Pratiksha, and Helene, all of them saying thank you very much for the talk. So great to see you three with us today. Going back to the Q&A, another question from Andrew Middleton, and perhaps this is best placed for you, Sonny. Andrew's keen to know a bit more about the technology stack that you're using for your model monitoring implementation.
Yeah, I'm not too sure how much into this I can go, considering like IP and whatnot. But I think what you want to do is use your kind of data platform and think of ways like that you could automate those monitoring tasks, and then also how you could implement like an alerting solution on top of that ideally, and then how you will consume those alerts and how they'll be serviced to people in your team or maybe in the business. So yeah, I'm afraid I can't go into like too much specifics, I think.
Perfect. No worries. I like to keep stuff a little bit secret as well. It gives that air of, secrecy. It keeps people interested. So thank you. I'm going to shoot on to the question from Michael Bateman now. He was interested, I guess, a little bit more general, I guess a little bit of history in terms of some positive use cases where you've spotted some situations where things have slipped a little bit or whatever. And Michael's asking what kind of problems have you uncovered? What's it look like in reality?
That is, again, quite a sensitive topic, because that involves us talking about what models we have deployed. But we can give an example, right? For example, if there's a flooding event happening, and our model might be predicting something, then because there will be more flood-related claims, that could have an impact in what the model is outputting. Right? So the business, right? They know that. Well, they know a flooding event happened, but maybe they haven't thought that actually that could have an impact on what the percentage of claims or percent of things our model is predicting. And then, yeah, to be able to understand that, it requires like, I don't know, maybe I'm not keen on weather forecast, watching weather forecast. So sometimes I don't know what happens. But in this case, right, we can see flood event happening. Those are features that can reflect. Those are flood related claims that could have an impact. But yeah.
Understand. Okay, perfect. Thank you very much, Dapeng. I guess following on from that, again, a little bit more of a general question, but I guess what are the risks if you don't monitor your model's performance?
Yeah, so I think first of all is the trust from the business, right? So if you are saying, oh, here's our model, we hand it over to you, we don't care about what's happening, but that's not very good relationship that you want to have as a business. So you need to be responsible for the models. So like from just the relationship side things, from the trust from the business, how they're going to use it, it's very important to be able to monitor that type of things. And then as Sonny mentioned, from the financial side, right, the model can change and that could have an impact on the financial side of things. So if we don't really understand what's going on there, right, model's predicting something, we might lose more money or we might gain more money or whatever. So it's be able to understand what's the impact of our model, because a decision is going to be made based on what we're outputting. So very important to know if something changed.
Perfect. And I guess there's potentially cases as well where other parts of the business are perhaps making changes, special offers, different things running, and that could have an impact on, you know, how your models work and things as well. So it's almost catching those things to keep that confidence. Yeah, perfect. Thank you very much. We'll keep going with the questions, and we'll go to the question there from Thomas. Thomas basically says, if I want to start with monitoring my models, from your experience, is it possible to recommend how to start, you know, educating in this area, interested in theory rather than the tool? So have you got any, you know, starting points for people that are watching at home that perhaps haven't done this before?
Yeah, I have to admit I'm in a similar situation. Before I started working on the project, I'm like, oh, where's the resources online to learn these things? So because a lot of the solutions online, it's well, they have their own solutions, right? Like, but then you don't know what's going on underneath. So what's important here is to be able to understand, okay, to be able to explain, this is how the data changed, and here is the reason why it changed. So those are things that's quite important to answer. And I don't feel that some of the solutions deals with that very well. So I would recommend that paper, which is earlier in the presentation about detecting concept drift review. So in there, they have a lot of different topics they mentioned there. So if you think, and those topics can suit different use cases or different business scenarios. So I highly recommend reading that, because here I covered more about what we learned, what is how do we approach it, but there's a lot more resources to detect different type of changes depending on what you want.
Perfect. And Thomas, the session was recorded as well, so you'll be able to watch the session back and check some of these links and things that Dapeng are talking about there to be able to follow up. So hopefully that's helpful. We'll keep going with the questions from Dave Mason this time. Dave's asking, do you use additional manual checks beyond the automated raised ones to ensure that your automated statistical tests are not missing unforeseen problems?
Sonny, do you want to cover that?
So that was, do you use additional manual checks beyond the automated ones? So is in terms of how that works?
Yeah, so the automated ones would be where you get the kind of the heads up, the alert, and then I think the data scientist then would, based on what they're assessing, based on the situation, what the data is looking like, there would be some element of maybe more manual checks as part of that investigation.
Perfect.
Yeah, and also just to add, I think, yeah, so we are talking about model monitoring solutions, right? But when we deploy a model, there's more KPIs that gets measured from the business side. And those are also things that we care about, because in the end, we want to deploy a model that's going to be useful for the business. So if that doesn't improve their KPIs, then there's no point us deploying or even doing anything to the models.
Yeah.
So yeah, there's a check from the business side as well too.
Fantastic. Yeah, it makes a lot of sense. Makes a lot of sense. We've got a few more questions to get through now. I'll come to the question from Indranil and then go from there. So Indranil starts off by saying, great session with an exclamation mark, which I definitely agree with. So that's good to see. His question, as he calls out, is from a learner's view. And he was asking, how do you efficiently perform exploratory data analysis and other operations on such real-time data with the least processing time? Is there anything you can offer from that side of things?
Let's see. Efficiently perform. So I guess, yeah, one thing is, again, like what do you want to measure? So maybe that will help you guide what EDA you want to do. So, do you want to look at the data? How is there a change in the data? How frequent is a change? What is the time period you want to change? Real-time data with least processing time. So in our case, yeah, we have a lot of features we want to do, right? So one way to make that faster is to use all the cores on the computer instead of just one core. So some machine learning libraries do that, but if you want to have your own solutions, then you need to utilize this multi-processing in Python to be able to do things faster. Perfect.
Thank you very much. We've got a couple of questions, I guess, conscious of time. So we'll go for two more questions and then draw things to a bit of a close. We'll go to the question here from Helene, first and foremost. Again, it's quite a general question in terms of the sector that you work in. But Helene's asking, do you think the insurance industry is catching up on the acceptance/use of machine learning because you're able to better explain how it works to your stakeholders? Or are there other reasons that it's catching up now? Do you think this is having a wider business impact on the industry? Who's going for that one?
Yeah,
Sonny or Dapeng?
Yeah, I'll go for that. Yeah, I think explainability is a big factor. So you want to be able to explain your model outputs, your model predictions, and why it's come to that decision, right? Especially if you're implementing your model in business processes. And also, just in general, I think it's getting more and more recognized that machine learning can be used to help improve and make business processes more efficient. So from my perspective, I'd say that's behind the take-up as well as the explainability side. I think the explainability side is quite important. The business needs to be able to understand why the model come to this decision and what are the influence behind it.
Yeah, that's a good point, because I think like we're talking about model monitoring, that's one way of explaining data, but there's also the explainability side of things, and those things are not necessarily related. So for example, yeah, going back to the case of fraudulent claims, we might assume, I don't know, Monday, there's usually more fraudulent claims. I don't know if that's true or not, just saying. So, right, so your model explainability tells you like which features is important, right? But then, certainly now you might not get claims on the Monday. Your model explainability is not going to tell you that. This is where model monitoring comes in and say, right, here's now change the data. We know what is important features, how those things impact. So those things work together.
Thank you. Again, makes a lot of sense. So we'll come to one final question. I'm conscious of time. We do try and keep this to that sort of lunchtime session for people that are UK based anyway. So we've got about a minute to go. And just before I get to that, just to call out a few more people in the chat as well. So Andrew Logan, Dave Mason, Thomas, Indranil, all saying thank you for the session. So thanks for being with us. And we'll come to the final question there in terms of from Andrew Middleton again. Andrew's asking, how much of the monitoring statistics do you feed back to the business outside of the data science team? So how much of this is for you, and how much of this gets kind of passed back to the business to get that relationship that you've talked about earlier?
So again, this is a little bit of sensitive question because, yeah, what do you tell the business? But I think one thing important here to mention is, the end user from the business, they need to have an understanding of machine learning as well. So if you just give them random stats, that's not going to be helpful for them. So it's very important for them to understand how, not necessarily exactly how the model works, but what is the model doing, how can the model impact the predictions, and then to be able then to interpret, right, now here's a metrics, and this is a reason why the metric have changed. But yeah, unfortunately, we can't give detail on what we are giving to the business, but yeah, very important for them to have this understanding as well.
Perfect. Anything final to add on that one, Sonny? Or we'll wrap things up with that. Dapeng's nailed it.
Yeah, it kind of ties up again with kind of explainability. So that's the side of it that you may want to give to business, and then the stats are more kind of internal.
Amazing. Yeah,
in terms of how we address the issue that's come up.
Yeah, makes a lot of sense. Makes a lot of sense. Awesome. So yeah, thank you both so much for being part of our masterclass month. It's been absolutely fantastic having you with us, and also, you know, I'd definitely like to just call out the wider team at LV. As I mentioned at the start, you know, they've been involved supporting the community for a number of years, and I know they've got of open sourcing some technologies later in the year as well, so doing some really great things in that area. And I think chatting with both the guys beforehand as well, they have got plans to potentially be hiring more people down the line, so I'm sure they'd absolutely love to hear from anyone watching at home as well. Just quickly in the chat, just as we're bringing it to a close, Christian, thanks to the speakers and to the Data Science Festival team. Hopefully see you in real life later in the year. We hope so too, Christian. Chris Lill, great presentation, thank you both. Richard Angle, thanks to Penn and Sonny. So yeah, people have definitely enjoyed it at home. So thank you very much for giving up your time and coming to share with us. We've definitely really enjoyed it, and yeah, we'll keep in touch. Hopefully to have you back at some point in the future, guys.
All right. Thanks
Thanks
for
very
the
much. Thanks everyone for attending.
Perfect. Thanks all. See you all again soon. Bye bye.
Thank you.